All right, so part 2 of this lesson, we're going to take all those things that we just looked at in part 1 and now try to show that x minus 2 and x plus 3 are factors of 2x to the 4th plus 7x to the 3rd minus 4x squared minus 27x minus 18. And what that means, to show something's a factor, you must show it goes in there evenly or divides in evenly. The easiest way to do this is use synthetic division. So if you set up your coefficients, now the tricky part to this is you can use either one, the x minus 2 or the x plus 3 first. You must show both. So if we say let's start with the x minus 2, that means 2 is your value for k. You're going to bring down 2, you're going to multiply and get 4, you're going to add, get 11, you're going to multiply, get 22, add and get 18, multiply to get 36, add and get positive 9. You should be able to answer why x minus 2 is a factor now, because the remainder is equal to 0. Anytime you have a remainder of 0, you know that this x minus 2 is a factor. Tricky part to this is, all right, well now we know x minus 2, if this remaining piece, this 2x to the 3rd, x squared plus 18x plus 9, that's really the part that's still, if I was to multiply x minus 2 times this whole polynomial, I would get back to my original statement. So instead of working with the original statement, I want to make my life a little bit easier, and I'd like to use these numbers again. I'd like to use these ones on the bottom and do one more synthetic division. This time I need to test that the x plus 3 is a factor. So here, now notice the coefficients I'm using. I'm using 2, 11, 18, and 9. Why? Because I want to make my life easier. I don't want to do more work than I need to. I'm going to use the smaller polynomial. I'm going to use this polynomial and prove that x plus 3 is divisible into it. What I do, I bring down the 2, I multiply, I get negative 6. I bring down, I add and get 5. I multiply and get negative 15, positive 3, negative 9, 0. Now, it's a factor. Why? Because the remainder is equal to 0. And last but not least, then find the remaining factors, and I go, well, if x minus 2, it went into there this many times, and if x plus 3 continued to divide evenly into it, and it went in 2x squared plus 5x plus 3 times, well, now I'm asking you to find the remaining factors, and this is a trinomial which is factorable, so you'd set up your 2x and your x. You say, all right, everything's positive, so I got to use plus sign. So plus 3 plus 1. You can double check me. That is the correct factored form here. All right, last slide coming up. All right, here's the trickier question. Here I'm giving you a polynomial, and in that polynomial, I am asking you, what are the zeros? Another way of saying that is, what are the factors? Very closely related. And what happens here, so what we have here is a nice application of, right now you have at best a guess. There are many numbers that could be the factors. What we have to do is be able to narrow that down, and the way you can narrow that down is by looking at two numbers, the 3 and the 2, the very last constant and the leading coefficient. And if you take the factors of 3, now the only factors of 3 are plus or minus 1 and plus or minus 3. Those go on the top of the fraction. And if you take the factors of 2, put those on the bottom, plus or minus 2 and plus or minus 1, a combination of the numbers up here over the numbers over here are the only numbers that could possibly be zeros. So for example, like 1 over 1 could be a 0. So 1 and negative 1 are possible zeros. So some possible zeros, I'll do possible zeros. You don't have to list these out at any point. But like 1 over 1, plus or minus 1 could be a possible 0. 1 over 2, so 1/2 could be a possible 0. 3 over 2 could be a possible 0. Or 3 over 1, so 3, plus or minus 3. Those are all the possible zeros. So there's really only 8 numbers I need to try. I guarantee our answers, there's going to be 3 zeros to our answer, and they're all going to come from this selection. So we really have here a 3 out of 8 chance of getting this correct, assuming that it does have 3 zeros. But I know it does have 3 zeros, so that's not always the case, though. But we'll cover that another day. Okay, so let's say maybe we thought that x plus 1 was a factor. If we did that, we would put 1 on the outside, and we'd do a little synthetic division. 2, 3, negative 8, and 3, and you would check by bringing down 2, multiplying 5, 5, here. Oh, I'm sorry. We could continue, add, get negative 3, negative 3. This one actually turns out, but I actually made a mistake here. The mistake I made here, right here, looking x minus 1. I said x minus 1 is a factor. I didn't test x. I didn't test x plus 1. What I really tested was x minus 1. Because don't forget, our value of k comes from the number after the minus sign. So that's actually, so we figured out that x minus 1 is a factor. X minus 1 is a factor. The factor would be 2x squared plus 5x minus 3. You may be asking yourself, where did I get that 2x squared plus 5x minus 3? And I'm going to say, every time you do synthetic division, it's still division. It's still the same as polynomial long division without all the variables attached to it. So I have my first factor right here. I'm going to continue to factor this, so keep the x minus 1. I'm going to continue to factor, get 2x and x. And it looks like we should be using plus 3 and minus 1. That's our correctly factored form. I did not ask for the factors, I asked for the zeros. So while these are all the factors, the zeros are 1, 1/2, and negative 3. And just to double check, notice all of these numbers were in our original estimates of, they had to be in the first way to narrow down, and using that instead of just guessing blindly, we had 8 numbers to guess between as opposed to an infinite amount of numbers to guess between. So that this little fraction here at the beginning can help you narrow down quite a bit. All right, I will see you in class tomorrow. Have a good one.